I will present term project and the title is Energy-Based Joint Variational Base, namely E-JoVaB. Presenter is Bengali in electrical engineering and the member of team is Taeyoung Kim in AI grade school and Hyung-Son in electrical engineering. The contents includes 5 sections and firstly I will introduce the first section. The introduction section has 5 subsections, preliminary of the required concept and the problem definition of that, and finally, contribution of this term project. This is Bayesian inference formulation, and in the study of Bayesian inference, there has been issues for the intractable wave posterior like this. So, Kingma proposed a paper of auto-encoding variational base, which is approximation technique with Q distribution instead of calculating the weight posterior directly like this for scalar divergence term in log py given x. The aim of this paper is minimizing the Kerr divergence between Q and P. However, it is also intractable Kerr divergence. Then, alternatively, it is same optimization effect by maximizing the evidence lower bound, namely elbow with respect to wave parameters. So, it can be formulated as this equation. Then, through the approximate method of variational inference, Bayesian inference can be implemented with well-approximated wave posterior. But still, there's a problem, as you can see in the checked red boxes. It is because, in fact, the wave posterior cannot be well approximated from simple assumption of QW because of P double given x and Px, where double given x can be estimated from variational inference for log Px. Therefore, we must estimate prior distribution Px for more approximating wave posterior. One of the research about approximating a prior Px is this paper. Wilgrath et al. Presents the paper Your classifier is currently an energy-based model, which is published in iClear 2020, and this is our paper. The author proposed energy-based joint distribution like this formulation, namely JEM, and the energy is formulated with the following equation. It can utilize both marginal likelihood like cross entropy and a prior distribution. So finally, it can optimize the joint distribution instead of optimizing each prior or each likelihood function. Besides, this paper shows outperforming classifier performance compared with the previous works, as you can see accuracy part. But in this paper of JEM, there is only performance-based explanation without satisfactory interpretation in latent space. In addition, it doesn't include variational inference for Bayesian neural network. So our contribution of our term project is second part, and first part is develop variational inference with joint energy-based model, namely E-JoVaB, enabling Bayesian learning with joint distribution. And second part is novel interpretation of Bayesian neural network with conventional variation inference and JoVaB. Purpose method. It is modified formulation of conventional variational inference. In the conventional formulation, log py given x is employed to expand variational inference, but in this term project, we will develop the joint variational base as follows this equation. And the expected log py px comma y given w can be decomposed with log py given x comma w and log px given w. Then it can be formulated this the following equation, and the elbow of JoVaB is the last term except the first scale divergence. Elbow is object function for optimization. Then elbow should be developed with dim learning output and expected log py given x comma w can be formulated like this through reparameterization trick. This is proposed by Yaringal, and the expected log px given w is also applied this technique, and the scale divergence between q and p can be written L2 regularization, which is also published in by Yaringal. And finally, the second term can be rewritten like this following equation through the JEM paper technique. This is brief flow for structure of E-JoVaB for classification task. If input image is propagated from neural network, then after softmax, uh, summation of py given x can be calculated, and after softmax and log summation exponential, the px given w can be calculated, and it corresponds to Elbow's terms, where wi is wave samples generated by neural network through dropout, which is Bayesian interpretation from Yaringal et al. Experiment. Baseline classifier uses just cross entropy without px, and joint energy based model uses cross entropy and px. Variation classifier is conventional variational inference published by Kingma et al., which uses expected cross entropy without px. Finally, E-JoVaB is our proposed method, and it is shown that E-JoVaB is superior performance to other methods theoretically and empirically. It is GradCam plus guided backprop version research. As different from other methods, E-JoVaB covers more informative and critical range in images, and E-JoVaB more represent large features, regions rather than other methods. Interestingly, when we train an input image for maximizing the prior with freeze wave parameters, JEM generates much ambiguous and not definite images rather than E-JoVaB. Because E-JoVaB has well approximated posterior, then we can see improved performances in terms of Bayesian inference or Bayesian generative model. Conclusion. This proposed method represents variational inference with joint energy-based model, namely E-JoVaB, offering improved classifier performance through Bayesian neural network with joint distribution. Second, as shown in experiment research, E-JoVaB more enlarges mainly activate gradient regions in latent space than those of conventional variation classifier and baseline classifier. It is because joint probably produces effective information between input images and its label, thus satisfying well approximated posterior fold Bayesian, which increases performances. Exploration. Yeah, this is a method. When we train input image for maximizing likelihood function, then the result of trained image is this image. And we cannot discriminate what the images represent for. Therefore, we can overcome this issue by exploring a new powerful design which has simultaneously generative model property and estimating prior property. For scalability to gain or latent space generator, generating PX neural network should be placed after decoder. If we place PX neural network before decoder and after encoder, then if we want to generate an image from latent code, we cannot utilize the PX neural network. However, if we place it after decoder, we can utilize PX neural network and simultaneously generating images by inputting latent code without encoder. Then we can resolve the issue which we dealt with in the previous slides. So far, we investigate variational inference and joint-based energy model. Then we propose E-JoVaB, which represent variational inference with energy-based joint distribution for improved performance, and a novel interpretation of Bayesian neural network. Finally, as the exploration structure and the feature work, as you can see this slide and previous slides, we expect this powerful idea of employing a joint distribution to work out joint variation inference for more broad tasks and various area. And from these slides, I can end up this term presentation. Thank you for listening to my presentation.